All right, my name is Nanadu Masamo Jr., and I'll be talking about the input and output concept in computer organization and architecture. All right. So first of all, I have some objectives that I want to talk about here. Well, I'll be talking about the intro, I'll give you the introduction to the input and output concept. Also talk about the basic input and output component, then the input and output system architecture. I also talk about the input and output bus and the communication techniques. And the last but not the least, I'll be talking about the I/O system diagram, right? So this is what I'll be talking about, right? All right. So what is so when we say input and output concept, we're actually talking about the system communication. Okay, we're talking about the communication between the CPU and the outside world, such as the users, the the storage, and the peripheral devices, right? So when you say peripheral devices, what does it mean? Peripheral devices is a component of a computer that is connected or hardware component that are connected to the computer system to add extra functions or functionalities to the computer. Okay, they are peripheral devices, and we can say that examples of peripheral devices, we have the printer, we have the disk drivers, they are all peripheral devices. Okay, so now that we've explained the input and output concept, as said, the input and output concept handle communication between the CPU and the outside world. That is the users, the storage, and the peripheral devices. Okay, so the communication between the CPU and those devices are what we call the input and the output concept, right? So they handle the, the, the communication system or the communications between the CPU and the outside world devices. All right, now what is input? When you say input, now input here is a data or signal, okay, received by the computer system from an input devices. The data or the signals received, okay, received by the computer from the input devices. So examples of input devices, we have what they call it, we have keyboard, mouse, we have microphone, sensors, they are all input devices, right? Okay, so when we talk about the output, okay, we actually referring to the data or signals received by the system from output devices. The data or signal received, okay, by the system from, okay, sent from the computer system to output devices. So here the data is sent from the computer system. That's the output. Okay, refer to the data or signal sent from the computer system to the output devices. And some of the output devices are the monitor, we have printer, okay, we have speakers, we have actuators. They are all output devices. Now, the next thing, let's talk about um, the basic input and output component. The basic input and output component. Now, when you say the basic input and output components, we are talking about the input devices. I have four here. That's the input device, the output device. We have the input and output models, the modules. We have the CPU and the main memory. Okay, the main memory. So the memory here, we talk about the RAM and the ROM. All right, so the components, we have the input devices, the output devices, we have the input and output bundles, we have the CPU, that is central processing unit, and we have the main memory, that is the basic input and output component. All right, so as we are talking about this component, let's look at what they do. Okay, what they do. All right, so one, they accept commands from the CPU. Since I said they handle communication between the CPU and the outside world, such as users, okay, storage and the peripheral devices. So here, so what they normally do is that the components, the accept command from the CPU. That's the IO system architecture, right? The IO system architecture, they accept commands from the CPU, and also they convert data, okay, format. They convert data format. As I've already talked about it, also convert data format. And last but not the least, here we have the handle error detection. They handle error detections, okay. They handle error detection. That's the input and output system architecture. They handle the errors detection. And the last one, they perform data buffering. They perform data buffering. All right, let's move to the I/O bus, the input and output bus. All right, so when you talk about the system bus is actually the combination of the address bar, okay. When we talk about the system bus, it's actually talking about the combination of the address bar, the address bus, the data bus, and control bus. Okay, the address bus, the data bus, and the control bus. That is called the system bus. It's a combination of data bus, address bus, and the system bus. That is uh, the the system bus, right? So let's look at the input and output bus. All right, it transfers data between CPU, the memory, and the input and output devices. Okay, so what it does is that it only transfer data. Okay, there's transmission of data from the CPU, memory, and the input and output devices. So I have a diagram here that talks about the IO system diagram. All right, so we have the CPU, that's the processor, we have the memory, that's the RAM and the ROM here, and there is a transmission of data passage. That's from the input devices, it goes to the input and output models, then it goes to the output. All right. So example, let's say I want to search about maybe the weather. Okay, the weather. So in this case, I will, with the help of my keyboard, I can enter, open my web browser, and I enter. Okay, now what is the weather going to be for today? Then I enter. So in this case, there is going to be a network, okay, a network that's going to be as a mediator to search or to convert what I've input into um, in such a way that it can come out with an output that I understand or see, right? So in this case, if I press the enter, is going to synchronize search on the web and find for me what will be actually for today's weather. So the moment it presents it on the screen, I'm actually watching from an output device, that is the monitor, right? So that means that the network here serving as both the input and output, right? So it displays it for me to the monitor, then also accepts the data. All right, so here I'm also going to talk about the diagrams, the input and output diagrams. All right, now before that, let's look at the bus. Let's continue with the bus. The bus, I said, it transfer data, okay, between CPU, the memory, the input, and the output, right? Okay, so one, what it does, so first of all, it has what is called the data lines. The data lines, now the control lines, and the last one, that's the address lines. The data lines, the control lines, and the address lines. Now the data lines, for what it does is that for actual data transfer, right? So if I input 1 plus 1 is also a data, okay? So data transfer, the communication, okay, the what it does before I get the information here. So here I have data lines. For actual data transfer, you have the control lines for signals like read and write, right? Signals like read and write. All right, I also have the address lines that to identify the input and output devices. That's the address line. For the work is that they identify the input and output, what do you call it, devices. All right, now let's talk about the input and output communication techniques, the techniques, right, the skills, right? Now I read here a programmed, okay. All right, so here first of all we have the program, the input and output communication techniques. One comes with one, the program, right? We have the interrupt driven input and output. And the last one, you have the direct memory access. All right, they are the communication techniques. Now let me explain the programmed input and output. Right now, CPU is fully involved in the input and the output operation. It pulls the input and output device continuously. So when talk about the central processing unit, it actually has a lot of functions, okay, in the lives of the input and the output devices. Okay, that's the central processing unit. It's like the brain, the processor. Okay, whatever that we input to the computer, now it just process it. Okay, it's the transmission that the computer or the CPU does. Okay, so here it configured it tries to make sure that it understand it and come out with a tangible what do you call it, output. So the input and the output system here, now here the CPU also has a bigger portion of part of it. All right, so the disadvantage is that the CPU remains busy or inefficient, right? That one is just listed as a maniac. All right, let's talk about the interrupt driven input and output. We are still on the communication techniques. All right, now the interrupt driven is that I/O devices interrupt the CPU when ready. Okay, free CPU to do other tasks, right? So they also interrupt the CPU and when ready. Okay, and we have the third one, that's the direct memory access. What it does, okay, it is a special hardware, that's the direct memory access controller, that transfer data between input and output and memory directly. Okay, directly reducing CPU load. Okay, that's the direct memory access. Okay, it's a special hardware, okay, that transfer data between the input and output and memory directly. Okay, so here for it to go to the CPU, for it to process data and giving it a big or a heckful load here, it just goes straight to the memory, right? So through the input and the output, now the system is fetched to the memory and it does the processing without what distracting the CPU whilst it is busy. All right, now that is about what that is the input and output concepts of computer architecture and organization. Now let's look at the system design. Okay, the system diagram. All right, the system diagram. Now this is the system. Okay, the system diagram. Let me turn it this way. The system diagram. First of all, I have the input. Okay, the input, what do you call it, the processor. I have the processor and also have the memory, right? I have the processor and the memory. Now the processor, this is the processor is actually the central processing unit. What it does is that now the implementation the computer does, okay, yes, so here it does some implementations anytime there is an input. Okay, now it has to go through the central processing unit, it processes the information, then it's come out with a data. Okay, so that's the processor handle that. And here we have the memory, that's the RAM and the ROM. Okay, the RAM is the random access memory and the ROM is the read memory. RAM is a volatile memory. Why? Because now data is lost when there is power off, and the ROM as the read-only memory here maintain data when there is power off. All right, so here this is a two model that they communicate. All right, how do they communicate? If there is an input here, okay, so if I type 2 plus 2 here, I press enter. Now when I press enter, now the keyboard has sent the data to the computer. So this is a model, that's the input and the output model here. All right, now here this input and output model here, now with the help of the processor, okay, now after it is done with the processing, okay, with the information that I wanted, it come out as an output here. Okay, then it's stored in the memory. Okay, then it's stored with it. Now where it is stored here, it is stored either stored permanently or temporarily. All right, so here that is the simple input and output system diagrams for the concept of computer organization and architecture. Thank you very much. My name is Nana Adumasamuja. Right, so thank you.